Assalamualaikum student. Today we discuss topic that is magnetic field of a circular loop. Magnetic field of a circular loop is stronger than that of a straight wire. So here we can write magnetic field of a circular loop is stronger than that of a straight wire. To understand the magnetic field of a circular loop, here we take a current carrying loop wire. We connect it with the battery and current is flowing through it in clockwise direction. So here in a coil, current is flow in clockwise direction. To understand the magnetic field of a circular loop, imagine that the loop is made up of the small segments which are approximately straight line. Each straight segment produces own magnetic field around it, which is in the shape of concentric circle. So here each segment of the circular loop produces its own magnetic field around it in the shape of concentric circle. Here we find the direction of the magnetic field by using right hand rule. Find direction of magnetic field. By right hand rule, the thumb represents the direction of the current and the finger represents the direction of the magnetic field. So here the current is flowing in the clockwise direction. So by using right hand rule, the current is downward. So and magnetic field is in the anti-clockwise direction. So here the current is flowing downward. So magnetic field is in the clockwise direction. In this segment of the wire, the current is flowing upward. So magnetic field is in the anti-clockwise direction. So it is in the anti-clockwise direction. So here we find the magnetic field is clockwise, and here the magnetic field is anti-clockwise. Here we see the magnetic field pattern for a circular loop. Magnetic field of circular loop is greater than that of straight wire. The magnetic field lines are circular near the wire, but as you move away from the wire, magnetic fields are circular near the wire head. As you move away from the wire, the circle becomes bigger and bigger. At the center of the loop, the magnetic field lines are approximately straight line. Magnetic field lines in the shape of concentric circles. These also are concentric circles. If in the coil, current is flowing in the anti-clockwise direction, so for each segment you need to align the thumb so that in the direction of the current, so that your finger will give the direction of the magnetic field. Here we using the right hand rule, the current is flowing in this segment of the wire is downward, so my thumb is downward, my finger is showing the direction of the magnetic field in the clockwise direction. So here we using the right hand rule and find the direction of magnetic field lines that are in the clockwise direction. So here the magnetic fields are clockwise. Here we use the right hand rule and we find that the magnetic fields are in anti-clockwise. So here the direction of the magnetic fields are in anti-clockwise direction. Here you can see that the magnetic field lines of all the segment of circular loop have the same direction at the center of the loop. Here direction of magnetic field is upward. Here is also the magnetic field of direction is upward. So all the magnetic field lines add up at the center and make the magnetic field stronger. At the center they give the straight line. So here we can write all the magnetic field lines add up at the center and make the magnetic field stronger. Here we can say that the one side of the coil is act as the south pole and the other side of the coil is act as the north pole. how we can say that this side of the coil is south pole and this side of the coil is north pole. Here we take the current carrying circular loop in which the current is flowing in the clockwise direction. So when the current is flowing in the clockwise direction, how we find which side of the coil is north pole and which side is south pole. If the current is flowing in the clockwise direction, if the current flowing in clockwise direction, then it is the south pole, which is denoted by S. So here the current is flowing in the clockwise direction, so this is the south pole, it is denoted by S. Here arrow shows the direction of the current. If the current flowing in anti-clockwise direction, then it is denoted by N, which show the north side. So here the N will show the north side if the current is flowing in anti-clockwise direction. So here arrow shows the direction of the current, that is the anti-clockwise direction. So in this side of the coil in which the current is flowing in the clockwise direction, so this is the south pole of the coil, and here the current is flowing in. So front side of the coil shows that the current is flowing clockwise, so it is the south pole. If we say backward, the back side of the coil is the north pole. Back side of the coil is the north pole, where the current is flowing in the anti-clockwise direction.